Alright, so this is the last part of the functions chapter. So we need to look at functions modeling. When using functions to model situations, 1. We need to form an equation involving one variable and sketch a graph. 2. Use the graph to determine the domain and range when using functions to model rules in real life. We need to make sure the domain has practical restrictions imposed on it. In other words, it's saying if you're dealing with time, make sure that the domain does not go in towards the negative domain. Or if you're dealing with money, again, you need to make sure you look at the particular context. For example, the area of a circle is determined by the function area is equal to pi r squared, so the domain represents the radius and must be r plus. So in other words, you can't have a negative radius. Okay, so the example here says, at a fun park, a motorized toy boat operates for 5 minutes for every dollar placed in the meter. The meter will accept a maximum of $121 coins. So write a rule that gives the time of boat operation B hours in terms of the number of N dollar coins. So for every 5 minutes, you will have to put in $1. So B in terms of, so our equation will be B is equal to, and N will be on this side. So we need to form this particular part, and we will have B is the number of hours, so how long will it take? 5N. Okay, but it's asking for hours, so we've got to be careful with this one, because if we put in 1 coin, it'll be 50 minutes. If we, 5 minutes. If we put in 10 coins, it'll be 50 minutes, but it wants it represented in hours, so we just need to go 5 divided by 60, because there's 60 minutes in every hour. So the equation actually is B is equal to 1 over 12N. And to be consistent with what we've been looking at in regards to functions, it's actually B is a function of N is equal to 1/2 of N. 1/12 of N. Now it says here, sketch the graph and the state the domain and range. So what we need to do is we need to understand where are we starting from. You could either put in 0 coins. Okay, you could put in 0 coins, and the machine takes a maximum of 120 coins. So we're going to be dealing from 0 to 120. We need to make sure that we draw our x-axis accordingly in that case. So we're going to draw a graph. I'm going to get a Cartesian plane up. And we're trying to sketch Bn is equal to 1/12 of n. We need to label this axis as n, and this is our Bn axis. When we get n equals 0, so at n equals 0, we get 0, because if you don't put any coins into there, it won't run. Now, can it be 0? We'll work that out in a moment. The next bit is 120 coins, so n is equal to, when n is equal to 120, we get 1 over 12 times 120, which is equal to 10. So n is equal to 10. So when n equals 120, you get 10. So what we can do here is join and extend. So instead of drawing on my tablet, I'm just going to use a line to indicate it. Okay, so at this point we can see the domain is quite clearly laid out. Instead of having to do this without a graphical representation, our domain of B is equal to 0 to 120. Now it can equal 120 because you can put in 120 coins, and it can equal 0 because you can elect to not put any coins in. The range of B goes from 0, and it can be 0, up to 10. Okay, so the next thing we have to do is work out the next question. So we end up plugging in, so 450 minutes, we need to convert that to hours. So 450 divided by 60 will give us 7.5. Okay, so 7.5 hours. And what we're going to do is we're going to plug in 7.5 into that original equation. So Bn is equal to 1 over 12n. We're going to plug in 7.5 is equal to 1 over 12n. N is equal to 7.5 times 12, which will give us around 90. So if you want this particular boat thing to operate for 7.5 hours, you got to put in $90 into this particular machine. And that concludes functions.